Automation is progressing all around us, and it is placing more complex demands on your power supply. Not only does your power supply need to be highly reliable and robust, but now you can additionally achieve high transparency in your application. With this transparency, you are constantly updated on the status of your power supply and the connected loads. This means that you can react faster, avoiding critical conditions. The CTOP PSU 6200 power supply gives you this advantage with its integrated diagnostics. The diagnostic monitor displays the current status of the device. These 5 LEDs indicate the operating status, the current load, and the operating hours of the power supply. The first LED indicates the status of the output voltage. A green LED means that it's okay. The other 4 LEDs together show the load. Now, starting from the bottom, we see that the one LED indicates that the PSU is loaded up to 30% of its capacity. Now, we can increase the load and show that the next LED shows up to 60% of its capacity is being used. In the last LED, we can increase the load up to 90%, and we see that the third LED is now green. Now, if your load should increase above 90%, as such, we will see that all 4 LEDs are now yellow. This gives you a direct visual feedback on your application. Now, don't fret. The PSU 6200 can deliver up to 120% of its rated power up to 45 degrees, so your application is covered. To further help you, the last LED will indicate the operating hours. Should it turn yellow, we know that the device has reached about its average lifetime of 10 years of continuous operation. The diagnostic interface gives you access to the information remotely. Let's take a closer look. At the first dip switch, COM or communication is set to 0, then the diagnostic interface on the right-hand side acts as a classic DC OK signaling contact. If we look to the next dip switch, HV or high voltage, we can shift the threshold value of the signal contact from 20 to 23 volts. For example, if you have to compensate for line losses. The third dip switch, PO or parallel operation, ensures that the loading of the 2 PSU 6200 power supplies is even while in parallel operation. But now if you want to increase the information from the PSU 6200, let's set the first dip switch to 1. Now the CTOP PSU 6200 permanently transmits information on your operating data, such as voltage, output current, and only requires one digital PLC input. This coded signal is deciphered by a function block on the PLC. All this Step 7 code and the visualization blocks are available for download online. Take a look. On the screen, you can see the status of the power supply and all the key values, describing the device itself, and the load voltage and current demand. If one of these values becomes critical, the device generates a status change. With the basics behind us, let's get technical. I will show you how to read out and visualize these parameters via diagnostics interface, giving you the know-how to integrate the PSU 6200 power supply in your automation system. The function and image blocks for the CTOP PSU 6200 power supply can be downloaded free of charge from the Siemens Industry Online support. They are available as a global library and are easily integrated into your TIA portal project. The associated application example provides the documentation for the implementation and is based on the global library and diagnostic interface. When you have downloaded and unpacked the global library, open the library in your project engineering. You should find the function block under types 01 blocks in the library. Under 02 types, you will find the PLC data type with the operating parameters. Function blocks and data types are available for the SIMATIC S7 300, 400, 1200, and 1500. In the 03 faceplates folder, you will find the corresponding image blocks for the comfort panels and the WinCC Runtime Advanced software. You can add the blocks to your project by simply dragging and dropping them. The function block has the input parameter impulse. This is the input in which you need to read the coded signal of the PSU 6200 at the input of the digital input module of your controller. The output parameters provide information about the current state of the block. The block provides the operating parameters of the PSU 6200 via the input and output parameter data PSU. To exchange the data, we use a data block with a PLC variable, which has the corresponding PLC structure as data type. To be able to use the picture blocks, you will need an HMI connection from your operator interface to your controller. To connect the data to the screen block, you need an HMI variable that references the associated PLC variable via the HMI connection. The global library provides two image blocks: an overview screen block, which displays the most important status parameters of the power supply, and a detailed picture block, and displays all the operating parameters of the PSU 6200. The data structure is connected via the interface of a screen block. The design of the block is determined, and the displayed trend curves for the voltage and currents are configured. The overview screen module offers the possibility to execute various events when touched. For example, a screen change to the detail screen module. Let's look at the detail screen module more closely. You can see that it consists of a header area, the status area, the navigation area, and the information area. Here in the heading area is the device name. In the status area, you will find a colored display of the current device status. The navigation area offers the choice between status information, output parameters, general operating parameters, and curve displays for the current and voltage value. As you can see, you can save hardware and engineering time with just one digital input and the appropriate components. Thus, you will always have an overview of the status of your power supply, so you can react in time to critical conditions.
Siemens, ingenuity for life.